everybody. I'm Wang, and I'm here with KK, and we're talking about what the big tech trends are in the latest Tech Trends book, 2025. So we've got it fresh off the copies here in Davos, and of course, we're at the HCLSoftware house here on the promenade. So welcome, KK.
Ray, always great to meet you.
We're super excited. Some of the big trends this year are AI, quantum, neuromorphic computing, robotics. They're all taking over the world. Let's talk about AI and what it's doing across different industries.
So, thanks, Ray. And when we look at AI, the first thing which we've been trying to use the term, it's not artificial. I think you have to start calling it augmented intelligence, applied intelligence, and even the theme around Davos is about in the intelligent age.
Yeah, and collaboration.
And collaboration. How do you collaborate better? So I think we believe that AI's purpose is to be with the human in the loop and really amplify, touch human lives, or technology which can touch human lives, but able to really help amplify the potential of what people can do better. It's AI to serve humans.
Yes.
And really up the overall value it can create, not just for the individual, for the company, the societies, and the planet.
And you're definitely right. It's when and where you insert a human is the question. It's not where you automate, but it's when and where you insert a human. And that's really the main point, is how do we actually do that significantly? The second piece that's actually happening is you're seeing AI permeate into different industries.
Yep.
So not just about AI in tech, it's AI everywhere.
Yep.
Talk a little bit about that as well.
So the way we are seeing AI is there is foundational building blocks, and one of the most important aspects in AI can only be successful if your data prep for AI is sorted. It's all about getting the right data and the definition of data, which is, I think, metadata, managing metadata actively, building a data catalog, data governance, data marketplace, data contracts.
Yeah.
Because if you get the foundational aspects of data, that feeds into training, that feeds into inferencing, that feeds into insights and learning back into the loop. Now, when you start to apply this to industries, it becomes very interesting that there is this every possible industry has an impact on AI. It's very interesting. It's no more just the usual financial services and banking and insurance and then big tech, but the real impact is every industry, starting from publishing to media to entertainment to retail to manufacturing to mining, even things like even the social sector, a lot in healthcare.
Oh, yeah.
You can use AI and infuse AI to really drive those pieces. But fundamentally, the big question which we'll have to still answer is, will data be all controlled using a fabric, or will it be a data mesh, which is a bit more distributed data governance, with governance more being federated but controlled in a still central way? It's going to be I think it's going to be a mix of both, continuously evolving.
Yeah, and in addition to that, we also see the fact that companies that have built a data strategy over time can do things like dynamic pricing. They can change how they address their customer experience. They have ambient experiences in the background that serve as nudges. And those nudges basically give you the ability to actually drive more personalization, learn from that, and continue the feedback loop. Now let's jump quickly into quantum. What's happening on the quantum side? Because that seems like way out there, yet it could be much closer than we realize.
The way I would say quantum computing is, as we really reach limits of how the current computing paradigm which exists today. If you go back, we had CPUs and we had floating point units.
Yeah.
And then from FPUs, you added GPUs just to take video, or you used to call them video cards.
Oh, yeah.
GPUs
They're gaming cards, video cards.
Yeah. And then slowly you had GPUs, and then you had other processing units. I think the hybrid classical quantum combination is going to be the one which you'll start to see something in the near future, where you will have, for a better namesake, call it a QPU, or a quantum processing unit, which basically coexists with a classical compute unit, where you can really start to offload certain type of algorithmic challenge. Now, the big difference is digital computing, finally, at underlying layer is silicon. Whereas quantum, you have different ways to build a quantum computer.
Oh, yeah.
And I would say, think of our computing has still always been built around math. It's a mathematic model which finally became computed. Think of a physics computer, a chemistry computer, a biology computer. And I think quantum, that's the single biggest uniqueness, that you could build computing based on the properties on which you are trying to model and compute around. the juries out there saying that which is the right quantum computing model.
Yep.
There are some absolutely interesting things with what's happening with various different technology companies building different types of quantum, whether it's a quantum annealer, whether it's a superconducting, whether it's a trapped ion.
Trapped ion, yep.
I was very curious. I met a interesting startup called PsiQuantum.
Oh, yeah.
They're trying to figure out using the origins of quantum physics, which happen on wave particle duality.
Yes.
Which is using photons
Yep.
and silicon to really build, which is the right, maybe one of the interesting approaches to build a quantum computer. But there's huge potential. We've been building some quantum algorithms, random number generators, a little bit of software capability. We have within HCLSoftware this concept called X, Y, and Z.
Yep.
So HCLSoftware X is about R&D around what is current.
Yep.
Y is our startup sync
Yep.
ecosystem, which is like a combinator model. And Z is a lot of work around deep tech and a lot of the quantum. We're trying to touch upon the deep tech to see how we can explain.
No, that makes a lot of sense. And especially with quantum, what we're really trying to get to is driving down those error rates. So we're actually seeing that reduce in the quantum error rates. And more importantly, the ions are getting much more stable.
Yep.
So the question is, what are the future? Are you using it for meteorology? Are you using it for
Climate,
upline, upstream, oil and gas, trying to look at mineral
Molecules,
production, material science. So all big areas. What about neuromorphic computing? Where are we headed there?
That's interesting because the most amazing computer is what we are.
0.6 watts.
Yeah, 0.6 watts.
Pretty efficient.
And it's an amazing piece that you need very little data to understand. Let's say if you want to teach a robot to catch a ball which you throw in the air, you have to teach it a lot of things like trajectory, elevation, angle of attack, how you grab it. Humans, the way the neuromorphic model is, it basically learns by patterns and do it a few things.
Is that RAM or ROM?
No one knows. I think it's neurons and the way they are wired up.
Yep. And we pass some things in our genes.
Yep, and there is some inherent knowledge which gets replicated and transferred. So I would say neuromorphic computing is absolutely this thing. There could be aspects around even genetic computing, which is talking about DNA-based computing. So we think that's an area which some interesting research is happening. Maybe it will, at some point on brain-machine interface and things like that will be significantly. But I would say you can start to tie neuromorphic with advancements happening in quantum and some of the other pieces will start to merge up at some point in time, Ray.
I think that's going to be big. Okay, so we hit AI. We looked at what's actually happening with quantum. We hit neuromorphic. The other big one's going to be robotics, right? I mean, you see that population is going to go from 7 to 8 to 7 and back down. Maybe we'll hit 9. We don't even know.
Yep.
But the point being is we're going to have less people on this planet. Who's going to do all the work? So tell me more about robotics.
Robot, I always say when you go back and watch and read science fiction, we've always been fascinated by android robots, correct? But we have so much robots around us which we don't even
maybe we
realize.
are the robot. We could be the robot. We don't know it.
Yeah, so we don't know that Ray always has this ability to be controversial. But I think So you're right. Are we programmed?
We've been programmed somewhere.
Yeah.
I don't know.
And there is a fine line between technology and spirituality. I would say a lot of quantum physics researchers have been using learnings from spiritual philosophies and other stuff to really understand. Like the concept of non-duality.
Yes.
Correct? It's basically which stemmed from the
and
Western
resonance.
philosophy. Yeah.
And resonance.
Resonance, correct?
Right.
Teleportation or things like that. The hypothesis is being developed.
Yes.
So coming back to where robotics is, I think there is huge amount of potential. Robots can be used to even assist humans. It could be used to even do dangerous jobs. It could be even used to be in safety, health. It could streamline production. It could also sometimes be used to alleviate fatigue.
Yeah.
There are so many other aspects. So robotics is something which we're really starting to see going to get applied in every sphere of our life. It is going to be in industrial, it's going to be in social.
Just like when we used to see industrial machinery come into place, right? Started with the arms, right? You walk into the Tesla plant, now you see all those robots that are actually there. The Optimus robots are moving, right? Pretty soon we're going to get to a point where countries like Japan might not have enough workers to actually fill their factories. Countries in China, which have an inverse pyramid, are also in the same boat, right? So we're going to see those robots actually play that role. It's not going to take away human jobs. We're not going to have enough people to actually do those jobs, is what we're worried about.
Yep, absolutely. And I don't think, See, that's where the responsibility for industries as well as enterprises and the government is to really start to shape policies in terms of how you adopt some of these technologies.
So, last question here, as we think about what's going on, what do you see? Are you optimistic about tech going forward, or are you pessimistic and worried?
See, I am always optimistic on tech because technology can really impact people's lives. And today, if you really start to see, like any technology evolution, if you take a look at what's happening, when you go back 50, 70 years back, when nuclear fission and fusion were invented, yeah, you could make a bomb, but your energy crisis, a lot of energy aggregation happened using fission reactors.
We're
and now
going to
looking at
need
fusion
multiple gigs of
gigawatt
and grids,
I'm looking at
and grids.
Yep. So technology, you can't. So it's about wisely using technology. The wisdom of using technology is going to be very, very important. I don't think you can roll back. See, you can say that technology is going to be disrupted, so it has to be this thing. And that's where the role of governments becoming very important to provide guardrails rather than regulations. I would say the word guardrails in terms of providing the guardrails to make sure that technology is used for the larger good. I think I'm optimistic.
This is great because the theme of Davos this year is really collaboration in this age of AI.
Yep.
You're going to see a lot of different types of collaboration, whether it's coming from private industry, governments, and of course customers that are in the way. So we're live here at Davos House, at the HCLSoftware House, and more importantly here on the Promenade in Davos, unveiling the new HCLSoftware Tech Trends 2025 book. Let's put it up there.
Yep.
So make sure you get your copy. There's digital versions and of course on the physical one.
Yep.
So thanks for being here, KK.
Okay. Thank you, Ray, as usual. Great.